Coordinate plane and order pairs. Lesson objectives: plot order pairs on the coordinate plane. Identify important parts of the line, and that would be the intercepts and the slope. Lesson objective: how are the coordinate plane and order pairs used in statistics? Well, you'll see as we get into linear regression, if there is a relationship between two quantitative variables, one variable can be used to predict another variable. The use of the coordinate plane and order pairs helps us visualize that relationship between those two variables. So we will use the independent, or in statistics we call that the explanatory variable, to predict the dependent, or the response variable. In your high school algebra class, you probably just used x and y. X is the explanatory, y is the response. So we'll begin with the coordinate plane. The coordinate plane consists of the x-axis, which is the horizontal one, much like a number line, and the y-axis, which is vertical. The point where they intersect is called the origin. They cut the plane into 4 equal sections called quadrants, and these are labeled by the Roman numerals 1, 2, 3, and 4. So let's take a look. Here's the 4 quadrants, 1, 2, 3, 4. You can see it goes counterclockwise. This is the x-axis. It's like a number line. Here is 0. Numbers to the left of 0 are negative. Numbers to the right are positive. And then now we have the y-axis. Here's 0. Values above 0 and the vertical direction are positive. Values below 0 and the vertical direction are negative. Next is the order pair. An order pair is used to show the position on the coordinate plane, where the x is the horizontal value, which is put first, and then the y, the vertical value, is second. And as the name implies, order is important. The first number tells you the x value, the second number tells you the y value. Order pairs are denoted by using parentheses here, and in statistics the explanatory variable is the first one and the response variable is the second. So it can be written as parenthesis explanatory comma response, or it could be the independent comma the dependent, or it could just simply be x and y. Here's an example of some order pairs on this coordinate plane. If we look at point A that has a certain location, and to write the order pair we start with the x first, the horizontal, and then we do the vertical second. So if I'm looking at A, I see on the x-axis A is at a positive 2 and then a negative 3 for the y. So the order pair for A would be 2, negative 3. Order is important. X comes first, then y. For B, B is here, so x is 3 and y is a positive 2. So the coordinates for B would be 3, 2. For C, here's C, x is negative 2 and y is a positive 3. So x is negative 2, so we have negative 2, positive 3. For D, which is down here, again we do the x first, that would be a negative 3, and then for the y would be a negative 4. So D is negative 3, negative 4. Okay, next is E. E is on the x-axis, so that tells us that the y value is 0 and the x value is a negative 3. So E would be parenthesis negative 3, 0. If we go to F, which is here, Okay, on the x-axis that's 0, on the y it's 2. So f is 0, comma, positive 2. E and F, once we look at linear equations, are what we call the intercepts. What point does the line intersect the x-axis or the y-axis? So now we're asked to plot the following order pairs on this graph. The first one is 3, negative 4. So we first start on the x-axis. We go to 3, 1, 2, 3, and then we go to negative 4. So that's below 0, 4 places. 1, 2, 3, 4. There's negative 4. This point here is 3, negative 4. Next would be negative 4, 3. Notice order is important, so this is going to be a different location. So now we go to the x-axis to negative 4, which is here, and then now we go up 3 on the y. 1, 2, 3. So that is this second point, and we can see that these are different locations, so order is important. Next we have 5, 0. X is 5, y is 0. So that is that third point. Next is 0, 5. X is 0, y is 5. That's up here. And last we have negative 6, negative 2. X is negative 6, which is here. Y is negative 2, which is here. And that is that last point. So let's look at a statistical application of the coordinate plane and order pairs. So here we have two variables, and those two variables put on the coordinate plane make what is called a scatter plot. So each of these blue dots that you see is an order pair, and if there is a relationship, we can use one variable, in this case latitude, to predict the value of a y, which in this case is mortality, deaths per 10 million. So that red line here is what we call a linear regression line, and you will learn more about this in future lessons, but this is the whole idea behind a coordinate plane and order pairs. It helps us visualize the relationship between these two variables, and then if there is a relationship between these two variables, we can use one variable to predict another. So each of these dots have both an x and a y value. Lesson objective. So for this lesson objective, we're going to just briefly talk about some fundamentals of what's called linear equations or linear functions, or in statistics they're called linear models. You may be familiar with the y equals mx plus b, which is a linear equation. The word linear means straight line. So first we're going to graph this linear equation. It will be a straight line, and once we get into the statistical concepts, we're going to let technology graph these, but I think it's a good idea just to sort of see where this is coming from and what these numbers mean. So if you've never seen this before, don't worry about it. I'll walk you through it, and we'll use technology in future lessons for this. For this example, we have y equals negative 2x plus 1. For the x values, we can pick those x values. Sometimes those values will be given to us, and then we plug them into that equation and get the corresponding y value. For the first one, x is a negative 2. We substitute negative 2 in for the equation. Follow the order of operation. Negative 2 times negative 2 is a positive 4, plus 1, and y is 5. So the order pair is negative 2, 5. Plotting that on our graph would give us this point right here. Next we do negative 1. We substitute negative 1 in for x. So we have negative 2 times negative 1 plus 1. We multiply first before we add. Negative 2 times negative 1 is a positive 2. Positive 2 plus 1 is 3. So we plot that point. Next is 0. Negative 2 times 0 is 0 plus 1 is 1. So the order pair is 0, 1, which is this location on the graph. And as we can see, there is clearly a straight line relationship going on between x and y. Next, x is a 1, y will become a negative 1, which is this point. And lastly, negative 2 times 2 is a negative 4. Negative 4 plus 1 is a negative 3, which is this point. When we have an equation that's in the form y equals mx plus b, and again we'll talk more about that later on, that is what we call a linear function, which means we can draw a straight line and all those points will be on that straight line. Now in statistics, we may not have any points on the line, but we just come up with the best line that models that relationship between the two. And again, we let StatCrunch figure out what the values of M and B are. Thanks for watching.